All right, so let's go over this review. So this does say graphing calculator section, so that means you get to use your graphing calculator as a reference. But for the most part, a lot of these you can do by hand as well, just saying. And I don't know about you, but sometimes it's easier to do things by hand than it is with the calculator. I feel like I'm more accurate than the calculator at times, so anyways. But there are times where we're gonna need to rely on that. So number one, it says at x equals 4, the function f of x equals 2x squared when x is less than 4, and 5x plus 12 when x is greater than or equal to 4. And we need to say if it's continuous, differentiable, and all that jazz. So to check to see if it's continuous, this is where we set the equations equal to each other. So 2x squared, does it equal 5x plus 12? And we test this out by plugging in the point that they have in common, and that is an x value of 4. So plug in a 4 for x, so we'll have 2 times 4 squared. Does that equal 5 times 4 plus 12? Well, 4 squared is 16. 16 times 2 is 32. 5 times 4 is 20. 20 plus 12 is 32. So yes, it is continuous. Okay, so if it's continuous, that means that it is going to be differentiable, or that it might be differentiable. Okay, so let's check that now. So for differentiable, so basically, if we know it's differentiable, then we can assume it's continuous. But if it's continuous, we can't always assume it's differentiable, because there are certain functions that are continuous that are not differentiable, like when it's a cusp or a corner or a jump, that type of thing. Okay, so if it's differentiable, this is where we take the derivative of each piece and set them equal to each other. So the derivative of 2x squared using power rule would be 4x. And the derivative of 5x plus 12 would just be 5. And the point in common is of x value of 4, so plug in a 4 for x. But we can see right away that 4 times 4 does not equal 5. So it is not differentiable, but it is continuous. So continuous but not differentiable, that's correct. Differentiable but not continuous, nope, we know it's not differentiable. It's not both, neither continuous nor differentiable, no, it is continuous. So the answer is A. Number 2 says, what is an equation of the tangent line to the graph of y equals cosine of 3x at x equals pi over 12? Okay, so we're looking for the equation of the tangent line, so we're going to need to take a derivative, and it needs to be at this x value, but that also means for the equation of the tangent line we need the y value, so we so far know pi over 12 is the x, we need to find the y value. So that means let's go ahead and plug in pi over 12. So cosine of 3 times pi over 12, plug it in for x. 3 goes into 12 4 times, so that is the cosine of pi over 4. Okay, well, let's refer back to our unit circle. Let's see, pi over 4 is the 45-degree angle. And we know that x is square root of 2 over 2, y is square root of 2 over 2. So cosine is square root of 2 over 2, and so is sine. So we can say, well, that means that the cosine of pi over 4 is square root of 2 over 2. So that means that the y value here is square root of 2 over 2. So this is the point we need to be using for the tangent line. Oh, that purple's weird. Okay. Anyways. All right, so we know that. Now let's take the derivative. So let's find y prime of this. So we have to use chain rule because we have to take the derivative of the inside. It has a function on the inside. So the derivative of 3x is a 3 times the derivative of cosine is negative sine, and then of the stuff on the inside. Okay. So I'm just going to clean that up a little bit. That's just negative 3 sine of 3x, okay? And we know that we're finding it at an x value of pi over 12, so plug that in. So negative 3 sine 3 times pi over 12. 3 goes into 12 4 times, so it's basically sine of pi over 4. Well, we know sine of pi over 4 is square root of 2 over 2. So that's negative 3 times square root of 2 over 2. Okay. Multiply straight across, we get negative 3 radical 2 over 2. And that's the slope. That's my m. Okay. So when I write the tangent line, t of x equals, the slope is negative 3 square root of 2 over 2. You just leave it just like that, times the quantity x minus pi over 12. And then the y value is square root of 2 over 2, so plus square root of 2 over 2. As funky as that looks, that's the answer. Number 3, if f of x is the function given by f of x equals e to the 4x plus 2, at what value of x is the slope of the tangent line equal to 3? Okay, so there's 2 ways that we could go. We could do this by hand or we could do it in the calculator. The calculator is a rough estimate, so it's not as exact. So we won't get these exact answers, but we'll get close to one of them. So I'm going to first show you on the calculator. Okay, so, and let's also write this down. So we'll put on Calc. Ooh, this pen is drying up. I think it's done. It was one of the ones in my classroom. It's gone. Okay, so step 1. We need to hit y1 equals and type in the function f of x into our calculator. Okay, so let's start with that. So y equals, and we'll put, what is it, e to the 4x. So second e raised to the 4x power, drop it down, and then plus 2. All right, there's y1. Then step 2, we need to type in y2, and that is the derivative. So we need the d dx of the y1 equation, x equals x, and then it's equal to 3. So instead of having 3 equals for the y2 there, we have to put it on the other side. So that means it would be a negative 3 on the other side. Okay, because we have to type it in as an equation. That's the tricky part, but it's something that we should know. Okay, so typing it in, I will have, where am I going? Oh yeah, math 8 for d dx. I need to put y1 in there, so I have to hit alpha, trace, and then 1 to type in the y1. X equals x, and then I have to put minus 3 to show this is where it is, a slope of 3. And then hit graph. Just a little slow. Just a little bit. I hope you guys had a good break. We did. Here's the second graph. We had a lot of fun. We went to Johnson Valley, did some off-roading. My son made it to the finger for the first time on his own without riding with someone. And that was pretty cool. It's the weirdest rock formation I have ever seen. All right, so I'm gonna hit trace, and then notice it's on the blue one. So I'm gonna hit arrow down, and now it's on the derivative graph because I need to see where it's crossing the x-axis. That will be the answer. So that means this is where the y value is 0. Looks like this is the closest I can get, but that's not even any of these. So that means I need to zoom in. So I'm gonna go to my window to zoom, and I'm gonna change it from negative 10 to 10 to negative 5 to 5. We'll graph it that way. Yeah, we had a lot of fun. It was pretty cool. We did that the first half of the week, and then we went with my family up to Lake Tahoe, South Lake Tahoe. We rented a house, and I have a huge family, and we had 24 people staying under one roof. It was pretty cool, and we had so much fun. We saw bears, we caught fish, we hiked, we played games, we watched the Dodger game, because that's just what we do. Trace, scroll down to get to the derivative graph, and I want y to be 0. And that's as close as I'm going to get. So negative 0.075758. So the closest one is B. So on the graph, this is what we're getting. We're getting approximately negative 0.076. Okay? All right, by hand will be a different story. Not very different, but it'll be a little bit different. Okay, so by hand, we need to take the derivative of f of x. And the derivative of e to the x is really easy. That's one of those definitions that we got to know. So you have to do chain rule because it has a function in the exponent. The derivative of 4x is just 4. And then the derivative of e to the x is just itself, so e to the 4x. But the derivative of 2 is 0, so that drops off, okay? And now it's at a tangent line equal to 3, so that means the slope is 3. So if the slope is 3, I could just plug in the 3 for f prime of x. Because remember, taking a derivative means I'm trying to find the slope, okay? And I just have to solve for x. So divide by 4, we'll get 3/4 equals e to the 4x. And I got to get the e out of there, so to do that, I need to take the natural log on both sides because I'll get a double base. So I'll have the natural log of 3/4 equals 4x. So now all I have to do to solve is divide both sides by 4. So x is going to equal whatever the natural log of 3/4 divided by 4 is. And I do have to use my calculator for that. So here we are. Natural log is down here. Natural log of 3/4 divided by 4 is negative 0.0719. So negative 0.072 if I round it to that thousandth spot there. Which is exactly what we get in B, okay? So that's why I like doing that type of problem by hand, because I'm gonna get closer to the answer, but another good way to back up is doing it on the graph. Sorry, I keep getting emails and I got distracted. All right, number 4 says, at which the following values of x is f prime of x undefined. So this graph is a graph of f, okay, but we know some things. We know that it's going to be undefined here because there's a jump, and it's going to be undefined here because there's a corner, and also there's going to be some vertical tangents right here at -4 and at -2. So it's not going to have a slope. There's going to be vertical lines there, or undefinedness, if that's even a word, at those points, -4, -2, 0, and 1. So at which of the following values of x is f prime of x undefined? Well, it's definitely undefined at x equals 0 because of the jump. X equals -3, well, right there, it would have a horizontal tangent, and that's okay. So it's not undefined there. And at x equals 1, we have a corner. So it's undefined at those two only. So that would be 1 and 3. So letter A. And for your notes, let's just put that at x equals 0, we have a jump. And at x equals 1, we have a corner. Turn page. All right, so here we have a free response question. So this is a nice little FRQ practice problem. Now, when you take your test, it's not going to switch back and forth from multiple choice to FRQ, multiple choice, FRQ. It's going to be all the multiple choice and then the FRQ. Or I think we're going to start with the FRQ and then get you guys going on the multiple choice. Remember, that is on Friday. Okay, so let's read this. And just for your future reference, I want to show you how I am going to grade free response questions so that you are prepared for that, because I'm grading it the same exact way that you're going to see me grade this. So it's going to be out of 9 points. Okay, let's get to it. A tank has been built to store rainwater and can be drained by opening a valve. The height h of t of water in the tank t hours after the valve is opened is given by the formula below. H of t equals 4 times 1 minus t over 13 quantity squared meters. So this has to do with the height of the water in the tank, okay? So of the water in the tank. okay? And T, the time, is in hours. Okay, so letter A. If the valve is opened after a large storm at 9:30 a.m. and remains open, at what time will the tank be completely empty? Explain how you arrived at your answer. Okay, if the valve is opened, okay, and it's staying open, at what time will it be completely empty? So we're measuring the height of the water in the tank, so we're not taking a derivative. We're just saying this is where H of T equals 0. Okay, so that means we're looking for where the Y value is 0. So let's go to our graphing calculator, handy dandy. Let me change the window back to normal though. So I had adjusted it. Hit Y equals, let's clear these out. And let's type in our function. It is 4 times the quantity 1 minus, I need to put the T over 13 in parentheses, so that'll be X over 13, parentheses, parentheses, square it, and let's graph it. Looks like it's gonna come down over here somewhere, so let's increase our window. Let's go negative 15 to positive 15. Actually, we don't need more on the negative side. Let's go negative 5 to 15 and see what happens. Okay. So we're looking for when the Y value is 0. We're getting there, getting there, getting there. Getting there. And keep going. Oh, went too far. Okay. So this is what I'm getting, approximately 12.727273. Okay. So we can say T will be approximately 12.7273 if I round it to the fourth spot there. Okay. Also on this graph, if I were to keep zooming in, I know it looks like it's crossing the x-axis, but it's not. It's just getting super, super close because it's not going to go down into the negatives. It's draining water, so it's going to be from full to empty pretty much. Okay, so it's not going to be a negative height. So we know it's not going to cross the x-axis. So let's explain. The graph comes close to the x-axis. Well, is this pen dying too? But doesn't, oh, it's got ink. But doesn't show crossing. There it goes. Dot, dot, dot. The closest is 12.7273. Okay. Another way to check this would be to do it by hand like I did on that one problem. So we'll just put by hand. This is what it would be, in case you're like me and like to double check it like that. So by hand, that you would take the function 4 times 1 minus t over 13 quantity squared, and you would set it equal to 0, because you're basically seeing when the tank is empty. When is the height 0? Well, if you divide by 4 out of both sides, 0 divided by 4 is 0. So you will get 1 minus t over 13 quantity squared equals 0 still. Then if you square root both sides, the square root of 0 is still 0. So you would get 1 minus t over 13 equals 0. These are really easy steps. Add t over 13 to both sides. You'd get 1 equals t over 13. Multiply by 13 to both sides. You would get that t equals 13. So approximately 13 hours. Yeah, I would say that. Okay, so it's super, super close. All right. And if you did it by hand, instead of doing it by graphing on the test, just make sure that you put your by hand answer in your write-up. Okay. All right, letter B says at 11:30 p.m. Oh, whoops, I forgot to finish answering it. Sorry, I forgot to finish answering letter A. It said, at what time will the tank be completely empty? So I'm totally running out of room. I took too much space. So this is still part A answer. So we'll say at T equals, I'll put my by hand answer, 13 hours after the valve is open, the tank, it says the tank, will be empty okay, so it was opened at 9:30 and it was emptied after 13 hours. So basically 9:30 a.m. till 13 hours later. Well, let's see, 9:30, 10:30, 11:30, 12:30, 1:30, 2:30, 3:30, 4:30, 5:30, 6:30, 7:30, 8:30, 9:30, 10:30 would be 13 hours. So at 10:30, and obviously this is p.m., will be empty at 10:30 p.m. So we could say h of 13 equals 0 using function notation. Okay, so this is part A. Took up space for part B. Oh well, that's okay. I might have to shift everything down a little bit. So we'll start letter B down here. Okay, so letter B. Going back to that. And also, before I move on, in parentheses there, that was just for our notes to explain what's happening on the graph, okay? We know that it's coming close to the x-axis. It's not going to cross because the height isn't going to be a negative number, all right? All right, sorry if that last one was a little all over the place, but I had to leave soon to get my son, so I left and came back. Man, an hour feels like 5 minutes. Crazy.
Oh, it feels like 21 minutes.
Lucas, go away. Okay, so letter B says at 11:30, the tank is full and the valve is left open until 1:45 a.m. So 11:30 p.m. to 1:45 a.m. Okay. How many meters of liquid waste have emptied from the tank by 1:45 a.m.? Okay, so we know that we are going from 11:30 p.m. to 1:45 a.m. So how many hours would that be? So 11:30. So 12:30, 1:30. That's 2 hours and 15 minutes. So as a decimal, that would be 15 minutes is how much of an hour? So 15 out of 16 out of 60 minutes, that's 0.25. So this is 2.25 hours. Okay, we need that, because that's how long the tank is draining. So we need to figure out what h of 0 is, so at the time of 0, how full is the tank? So let's figure out h of 0. So that will be 4 times 1 minus 0 over 13 squared. Well, 0 divided by 13 is 0. 1 minus 0 is 1. 1 squared is 1. 4 times 1 is 4. So the tank is starting off with 4 meters of liquid. Okay, now let's find how much liquid is left after 2.25 hours. So that would be 4 times 1 minus 2.25 over 13 quantity squared. What does that equal? And I'm going to move C down, so we're going to cross that out. All right, so I'm going to use my calculator. Let's see. So 1 minus, I'll use parentheses, 2.25 divided by 13, and then square it, and then multiply by 4. 2.735, if I round it to the thousandths. Okay. So I want to figure out how much is left in the tank, or how much has been emptied from the tank. So if we started off with 4 meters and we're ending with 2.735 meters, to figure out what's left, we just take h of 0 minus h of 2.25. So that's basically 4 minus 2.735. 4 minus 2.735 is 1.265. Okay. So let's write up our answer then. This is an FRQ, so our FRQ always has to include a write-up of some kind. So we can say at 1:45 a.m. there will be 1.265 meters emptied from the tank. And we have our work to back up that answer. Okay, so notice I'm boxing the answers here, and let me show you so far what you would get points for. Okay, you would get 1 point for your write-up right here, and it has to include all of this in order to get the full point. Okay, so the fact that you're saying t equals 13 hours, or even if you said 12.7273, that would be the same. Showing that work tells me that that's where you get that from. Plus, you're using the calculator, so I'm not expecting to see a whole lot of work for that because you could have used your calculator. Okay, if you are doing it by hand, though, you got to show me how you got it by hand. All right, for part B, there are 4 things here that you're getting a point for. You're going to get a point for finding the initial height. So +1, I should put pluses in front. So the 4 meters. You're getting a point for finding the height at the time it stops. So 2.25 hours, it's at 2.735 meters. You get a point for finding out that the amount that was drained was 1.265 meters. Okay, and then you get a point for the write-up. So that was worth 4 points there. Okay. All right, let us see. We'll use purple, and we'll cross out the D. We'll just have to shift everything down. Okay, letter C. Says, what is the value of h prime of 3 using correct units of measure? Explain what this value represents in context of the problem. Okay, so what is the value of h prime of 3? That means we have to take a derivative. Okay, and that means that we can do that on our calculator. Okay, so we are going to be using our calculator for this, and we already have the function typed in. I have it right there. So for y2, I can do the derivative in here. You just hit math, 8 d dx, and then I need to put in the y1 function, so alpha trace y1, x equals x, and graph. Okay, we're looking for the x value at 3. So that's what's going to be nice about here. We won't have to just find it on the graph. We will be able to find out exactly what it is using our graphing calculator. So I'm just waiting for it to finish. Okay, so I have to second calculate 1 for the value. We're plugging in an x value of 3, and it's going to tell you exactly what that y value is. But notice it did y1, so you have to scroll down for it to do y2. And at x equals 3, the y is negative 0.473373. So negative 0.473 is what I'm going to write down. So I should put a wavy equal sign because it's approximately negative 0.473. And we have to use the proper units. This is in meters per hour. Okay. And we need to explain in context of the problem. So let's do our write-up. Oh, what color do I want to use? I'll use green. So we can say h prime of 3 is the rate the water is being emptied at t equals 3 hours, because that's the time that was plugged in, after the valve is opened in meters per hour. Because the explanation part was just in context of the problem itself. Okay, so here's where the point would be from. You would get a point for this part right here, the h prime of 3, and finding the negative 0.473 meters per hour from the calculator, and then a point for the write-up. And then for part D, says the waste is draining, or is the waste draining faster after 15 minutes or after 3 hours? Justify your answer. Okay, well, we know how fast it's draining in 3 hours. We found that on the calculator. Well, how fast is it draining in 15 minutes? So we're gonna need to use our calculator again. But what is 15 minutes in terms of a decimal? Well, 15 minutes is what fraction of an hour? Well, 15 out of 60 minutes in an hour, that's 0.25. So 0.25 of an hour. So for your notes, let's put that represents 15 minutes. Okay, and we're gonna find out what this is on our graphing calculator. So I'm gonna go back to the graph. I'm gonna hit second calc, 1 for value. I'm gonna put in 0.25, hit enter. But again, it always does y1 first because it's y1. Scroll down to y2, and this is what we're getting. Negative 0.604 if I round it to the third decimal place there. So negative 0.604. This is in meters per hour. Okay. All right. Well, let's see what we have here. We know that in 15 minutes, its rate is negative 0.604 meters per hour. So negative just means that it's emptying out. It's decreasing the amount of liquid in there. So it's, yeah, negative slope. So this one's 0.604 meters per hour. This one's 0.473 meters per hour. Okay. Well, this is technically greater, even though we're not looking at the negative. The negative just means that it's being emptied. Okay. So this one has a greater rate, which makes sense though. Like if you think about it, if a tank is full of liquid and you're draining it from the beginning when it's full, it's going to drain faster because it's full. And then it's going to start slowing down as it gets closer and closer to the bottom because it's running out of water, so we don't have that pressure to push it out. Okay? So this one is actually greater. So what would our write-up look like? Well, we could say rainwater is draining faster after 15 minutes since, we have to justify our answer, since h prime of 0.25 is greater than h prime of 3. Let's use an inequality statement. And there's our write-up. So for this one, you would get a point for finding the meters per hour at a time of 15 minutes, and then a point for your justification. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 total, and that's how it would be scored. So notice how everything builds, and your other FRQ is very, very similar to this. Okay, so now we're on to the non-calculator multiple choice section. Checking the time, I have 20 minutes until my next class, so I have time. Okay, so it says if the line 2x minus 3y equals 24 is an equation of the normal line to the graph of f of x at the point -1, 5, then what is the value of f prime of -1? Okay, well, it says that this is the equation of the normal line to the graph. Okay, so let's take this and let's put it in slope-intercept form so that we could see the slope, because we know that the slope of the normal line is perpendicular to the slope of the tangent line, and the tangent line slope is basically the answer to this question. Okay, because when an x value is -1, what's the y value? That's basically finding the slope of f prime, okay, at that x value. So let's take the 2x minus 3y equals 24. Sit down, and if you run around again, you're going to be in some major trouble. Sorry about that, guys. I've had to keep stopping the video to yell at them, like, frequently. Okay, so I'm going to subtract 2x. I get -3y equals -2x plus 24. And then we need to get rid of that -3. So divide everything by -3. And we'll get y equals 2/3 x minus 8. Okay, and all I care about is this. So this is the slope of the normal line. So I know that if I find its opposite reciprocal, that's the slope of the tangent line. So the opposite of positive 2/3 would be negative, and the reciprocal of 2/3 is 3/2. So -3/2 is the slope that I am looking for. So the answer is D. All right, the next problem, number 6, this one is one of my favorites. I really like this problem. Okay, so it says, given that f of x and g of x are differentiable functions and the following function values are true, find h prime of a if h of x equals f of g of x. Okay, this is one of those composition of function problems. Now, there was a rule, a specific rule that we could use, so you can look up that definition. I did mention you guys needing to put that on an index card, but I didn't write this one on an index card. It's easier to just know how to come up with it than to try to memorize it, in my opinion. Because when we find the derivative of h of x, all we're doing is the chain rule. This is the inside function, so I need to take the derivative of that, so we'll have the derivative of g of x times the derivative of the overall is f, so that would be f prime of, and when you write f prime of, you just keep the stuff inside, so of g of x. Okay, or you can just memorize that rule. It'll always be that way. Up to you. I'd rather just use chain rule because it's just easier instead of forcing myself to memorize it. Okay, so h prime of a then would equal g prime of a times f prime of g of a. Okay, so let's start with g prime of a. From our list here, we have g prime of a is equal to c. So c times f prime of, I have to work on the g of a first. G of a is d. Okay, and then f prime of d is what I have to do next. So I have c times f prime of d is equal to 5. So this is just 5c. Now, all those other options are possibilities that you could get legitimately, but not with the right format. So your formatting needs to be good, okay? Because you could get these other answers if you forget a prime or if you do it in a weird order. So just be careful, okay? This will always be true. When h of x equals f of g of x, it's always the derivative of the inside times the derivative of the overall with the inside, okay? That's important. All right, number 7 says the piecewise function f of x pictured to the right consists of segments of linear functions. Which of the following statements is/are true? Letter I, f prime of -2 equals 0. So this is basically saying that the slope at an x value of -2 is going to be equal to 0. Well, at -2, if I look at this, the slope isn't 0. This is not a horizontal slope. This is a decreasing slope. So that is definitely false. This is not true. Okay. F prime of x is going to be greater than 0, so it's going to be a positive number, so it's an increasing slope. On the intervals, -4 to -3. So -4 to -3, that's this interval right there. Yeah, that's an increasing slope, so that's true. Is it also an increasing slope from 0 to infinity? Well, it's increasing right here. It's increasing right here, but then it decreases right there. So from 0 to infinity, it doesn't increase the whole way. So that's false. So since one of them is false, the whole thing is false. Okay, so far false and false. Let's check the third one. F of x is continuous at x equals 3, but not differentiable at x equals 3. Well, at x equals 3, we have a corner. So yeah, it is continuous there. There's no jump or break or anything, but it's not going to be differentiable there. So this one is true. So only the third one is true, so B is the answer. Okay. Number 8. So it says if h of x equals the square root of g of x, and g of 2 equals 12, and g prime of 2 equals -3, what is the value of h prime of 2? This problem is similar to number 6. Okay, so we have h of x equals the square root of g of x. And it helps when we write this as g of x to the 1/2 power, because we're going to have to use power rule to take its derivative. Okay, we need to take the derivative of h of x because we need to find the value of h prime of 2. So that same little thing that we came up with in there, but I like to use chain rule. So the derivative of the inside, so that'd be g prime of x, times, we got to bring the 1/2 down because we have to do power rule on the overall, of g of x to the 1/2 minus 1 power, so -1/2 power. Okay, so that's what we've got going on right there. That's why I like to use chain rule instead of memorizing something, because you might think differently. We have to use power rule on that. It's a different function than the one in number 6. Just got to be careful. Got to be careful. All right, so now let's find h prime of 2. So that means it's going to equal g prime of 2 times 1/2 times, well, because it's a -1/2, it means it's in the denominator, so it's the square root of g of 2. I know that looks funky, but yeah. Anyways, can't make it look any better than that. All right, so now we know g prime of 2 was given to us. It's a -3. So -3 times 1/2 times the square root of g of 2 they gave us is 12. Oh, why did I put 14? It's 12. Okay. All right, so if I multiply this straight across, I'll get -3 over 2 square root of 12. -3 over 2 square root of 12. Oh, it's B. What's nice about calculus is that we don't have to rationalize. We don't have to simplify those radicals all the time. There are certain problems where you do, but for these ones, yep, you're done. Like it. Like it a lot. Okay, so now we're on to the second free response question. Okay, so there will be 2, just like this. Okay, so your test is pretty much going to look like this review, just different numbers and slightly different questions, but the same concepts. All right, so it says non-graphing calculator, so I'm not going to use my graphing calculator for this. Okay, and it says let f of x be defined by 3x minus x squared when x is less than or equal to -1, and 2x squared plus kp plus p when x is greater than -1, where k and p are constants. If k equals 4 and p equals -2, is f of x continuous at x equals -1? Justify your answer using limits. So this one's like a blast from the past problem. Okay, so let's first take a look at if it's continuous or not. So I'm going to squeeze that in up here. Is it going to be continuous? So if it's continuous, we have to set the two equations equal to each other. So 3x minus x squared equals 2x squared plus kx plus p. Okay. And the x value in common is -1, so we're going to plug that in. But they also are giving us that k is 4 and p is -2, so we're going to plug those in as well. So we'll have 3 times -1 minus -1 squared. Is that going to equal, so put a little question mark. Well, let me zoom in a little bit for you guys. 2 times -1 squared plus k is 4, so 4, and then x is -1, and then plus p, but p is -2, so it's going to be a -2. Okay, let's clean this up. So 3 times -1 is -3. And then -1 squared is 1, but then there's that minus out front, so it's -1. -1 squared is 1, 1 times 2 is 2, 4 times -1 is -4, and then -2. So we have -4 equals 2 minus 4 is -2, -2 minus 2 is -4. Hey, we got the same thing. So yes, it is continuous. Okay, and guess what? Showing this work is the first point. This one's also going to be out of 9. Okay, so that's the first point, showing that it's continuous. Okay, so now we need to do our write-up. So we can say if k equals 4 and p, wait, can you guys see? And p equals -2, then f of x is continuous at x equals -1, because we have to say it's defined, because f of -1 is defined. And, all right, and, I lost my spot. Oh, sorry. And the limit as x approaches -1 from the left of f of x equals the limit as x approaches -1 from the right of f of x, which is equal to f of -1 because it's defined. And that is our write-up. Okay. And you would get actually 2 points for this write-up. So I would probably break it up based on your limit statement and stating what are the conditions. Like you have to have k equal 4 and p equal -2 in order for this to be continuous. Okay. All right, so that was part A. On to part B. So it says if k equals 4 and p equals -2, is f of x differentiable at x equals -1? Justify your answer using limits. Is it differentiable? Okay, so let's put our differentiable work over here so we could leave space over there to do our write-up. So differentiability has to do with taking the derivative of each of those functions and setting them equal and then plugging in all the stuff. Okay, so let's take the derivative of 3x minus x squared. Well, the derivative of 3x would be 3. The derivative of -x squared would be a -2x. And then the derivative of 2x squared would be a 4x. The derivative of kx would be a k, so plus k. And then the derivative of p is just a constant, so it would be 0. Okay, so let's plug in all the things. We'll have 3 minus 2 times negative 1. So 4 times negative 1, and k is a value of 4. Okay, so let's see, negative 2 times negative 1 is positive 2, so 3 plus 2 is 5. 4 times negative 1 is negative 4. Negative 4 plus 4 is 0. Oh, these are not equal, so it is not differentiable. Okay, so you're going to get a point for showing that it's not differentiable, so that work is very important. Okay, now let's do our write-up then. So I'm trying to decide. I guess I'll keep my write-ups in green. I'll be uniform. So we can say if k equals 4 and p equals negative 2, if k equals 4 and p equals negative 2, then f of x is not differentiable at x equals negative 1 because, and this is where our limit statement comes in, because the limit as x approaches negative 1 from the right, or sorry, from the left of f prime of x does not equal the limit as x approaches 1 from the right of f prime of x. And you would get a point for that write-up. Okay. And the reason why it's not 2 points is because after this part, you should already know that you need to include the if k equals 4 and p equals negative 2. You already know that you need to include that part, so I'm going to assume that you're just going to continue doing that. And so the only new thing you're adding is that limit statement showing that it is not differentiable, that the limits are not the same. Okay, letter C. So it says that for what values of k and p is the function f of x both continuous and differentiable at x equals negative 1? Okay, so you've done a few of these problems before for homework and stuff, but we haven't been tested on this part of it quite yet. Okay, so to show that they're continuous, they have to be equal. So that's where we set the 3x squared minus x squared equal to 2x squared plus kx plus p. But this time, we'll plug in the negative 1 for x because that's the point they have in common, okay? But we're not going to plug in anything for k and for p yet because we're finding what they need to be to make them both continuous and differentiable, okay? So let's plug in that negative 1. Oh, wait, did I write this wrong? It's 3x minus x squared. Sorry, I keep getting distracted. My children are not being behaved right now. Okay. So I'm going to keep going. 3 times negative 1 is negative 3. Negative 1 squared is 1, but there's that negative out front, so it's a minus 1. Negative 1 squared is 1. 1 times 2 is 2. K times negative 1 is a negative k, and then plus p. Negative 3 minus 1 is negative 4. Okay. All right. And let's go ahead and move that constant of 2 over. So we will subtract 2 from both sides, and we'll get negative 6 equals negative k plus p. And we'll stop there. Okay, because that's as far as I can go with that. All right, now let's do the differentiable side. So the derivative of 3x minus x squared would be 3 minus 2x equals the derivative of 2x squared would be 4x. The derivative of kx would be k. The derivative of p would be 0, so it's just 4x plus k. Lucas, stay in that seat. Do not move. Get to work. Okay, so now let's plug in the -1 for x. So 3 minus 2 times -1 equals 4 times -1 plus k. So that's going to turn positive. 3 plus 2 is 5. -4 plus k. Oh, we can solve for k. Woohoo! Add 4 to both sides, and we're going to get that k equals 9. All right, so let's go and plug that in for k right here. So we'll have -6, can you guys see, equals -9 plus p. Add 9 to both sides. -6 plus 9 is 3, so p equals 3. So we have k, we have p. So these are the values for k and p that will make it both continuous and differentiable. And it didn't ask for a write-up on this one, just the work. So you would get a point for your work showing continuous, a point for your work showing differentiable, a point for your answer for k, a point for your answer for p. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So add a 9. It's beautiful. And that's the review.